All right, we'll probably have some more people join us in just a minute, but let's go ahead and start. Chapter 4 is all about using the derivative, first and second derivative, to be able to determine things about a graph of a function that we could not have determined with just algebra. If you think about, well, if you had me for college algebra, when we were graphing polynomial functions, we would say if the degree is even and the leading coefficient is even, then both ends go down. But we couldn't really tell. We could tell where the graph either touched or crossed the x-axis at each zero, but when the graph crossed the x-axis, we really didn't know how high it went up. We knew it crossed the x-axis and at some point turned around, but we couldn't tell how high it went up. And with parabolas, of course, we have a way of finding the high point and the low point of a parabola. It's going to be at the vertex. But anything that's higher degree than a second degree equation or any transcendental function, up until now, we haven't been able to find those high and low points. And that's what all of chapter 4 is basically about. There was some new terminology in 4.1. The definition of an extrema is just f of c is a y value. That y value is the minimum of a function on the interval if it's lower than all the other y values around it. And f of c is a maximum on an interval if y is greater than all the y values around it in the interval. And the minimum and maximum of a function are the extreme values, and they're also called the absolute minimum or absolute maximum. Wait, let me read something real quickly. Yeah, they're called the absolute minimum or absolute maximum on that interval. The absolute highest point on the interval or the absolute lowest point on the interval. Theorem 4.1 said if a function is continuous on a closed interval, then it's going to have both a maximum and a minimum on the interval. So looking at these pictures, 4.1, we have a closed interval. Closed interval just means containing the endpoints. And on that closed interval, there's a minimum value at 0, 1, and there's a maximum value at 2, 5. And then in the B part, that is an open interval because the endpoints have open circles on them. There is still a minimum on that interval because there's a closed dot on 0, 1, and 1 is the lowest y value on that interval. But in the B part, there's not a maximum because you can get infinitely close to where y equals 5, but you can't get y equals 5 when there's an open dot right there. And then the last part of that illustration, here is a closed interval, includes both endpoints. The maximum occurs at 2, 5, but this low point where the tangent line would be horizontal is not a minimum value because at 0, y is not 1, it's 2. So that's not the lowest value. Actually, there's not a lowest value on that graph. There's not a minimum because the graph can get, the y values can get infinitely close to 1, but aren't actually going to get to 1. All right, I want to point at 2 other things in the book, and then I'm open for questions. The definition of relative extrema is just, as opposed to this definition of an extrema, this extrema was the absolute lowest point or the absolute highest point on a graph. This is just relative extrema, higher than what's around it or lower than what's around it. That's what relative indicates. So relative max and min, you can also call a local max and min. And the definition of a critical number, the important thing about this definition is that in order to be a critical number, the function has to be defined at C. If a function's not defined at C, then C can't be a critical number. But if a function is defined at C, then if the derivative is 0 or undefined at C, then C is a critical number of the function. Now, here you couldn't say C is a critical number because the function's not defined at sharp turning points. Here you could say C is a critical number because because f of C is defined and the derivative is 0. This theorem 4.2 says a function has a relative min. If a function has a relative max or min, then C has to be a critical number. You're not going to have a relative max or min at any points other than critical numbers. Now, the reverse of that is not true. It's not true that if C is a critical number, it's automatically a relative max or min. We'll see some examples where that's not the case. And last thing, this tan box on page 209 tells you how to find the extrema on a closed interval. You find the critical numbers. You evaluate the function at each critical number and at the endpoints. The smallest one of those y values is the minimum. The highest one of those y values is the maximum. So you give me a function, like example 2. I'm going to note that this function's defined from negative infinity to infinity, so I don't have to worry about anywhere the function's not defined. I'm just going to find the critical points by setting the derivative equal to 0 and finding those x values that make the critical numbers equal to 0. I'm going to find the function values not only at 0 and 1, but at these endpoints we were given -1, 2. I'm just going to make an XY chart with 4 x values on it, 0, 1, -1, 2, and I'm going to find all the y values. The highest y value is a maximum value. The lowest value is a minimum value. All right, y'all probably didn't even need that. If you watched the video for some crazy reason, I couldn't stop myself. It's the teacher in me that has difficulty not pointing out all the important definitions and new vocabulary and any coffee stains on my paper. I'm sorry. What do you need to ask me? 4.1's pretty easy, but if you need to ask me something, we're open.
Number 19.
19, okay. Page 211. Number 19. All it says is find the critical numbers. Tell me again what the definition of critical number is. What does it mean to be a critical number?
Oh, that's not my number 19. That's my number 23.
Okay, this must be my 6th edition homework then. What is your number 19?
Mine is h of x equals sine squared x plus cosine x.
Okay, that's weird. That's my number 15. I've thought I corrected all these page numbers. problem numbers. All right, number 19. Now tell me what a critical number is.
It's like a number where change happens in the graph, something important happens.
Yes, but I didn't ask that well. How do you find critical numbers?
You take the derivative and see what makes it 0 or undefined.
And so automatically anything that makes the derivative 0 or undefined is a critical number? Is that the first thing I should do? Just find the derivative and what makes it 0 or undefined, and that's my answers? Somebody say no.
No.
Why?
Because one of the numbers you get out of that might not be the lowest or the highest point.
Well, it didn't ask me to find the lowest and highest point. It just asked me to find the critical numbers. This is one of the things that I just pointed at in the book. The definition of a critical number is not only the derivative is 0 or undefined, it's the function has to be defined at C. So anytime you're looking for critical numbers, you first need to note the values for which the function is undefined. For example, this problem, if you didn't give me that restriction, you just said find the critical numbers, a critical number could not be, for example, 5, because in this one, you couldn't let t be 5. Make a note of the domain of the function and all the values that are excluded from the domain, and then other than those, you can say, other than those, anything that makes the derivative 0 or undefined can be a critical number. So what's the domain of this function? Is there anything x cannot be? What's the domain of sine and cosine? All right, I'm gonna have to see who's here. And
all real numbers?
yes, yeah, you can take the sine of any real number and the cosine of any real number. So this particular problem, we may have been okay skipping that step because the domain is negative infinity to infinity. But on another problem, if we skip that step, we may say something is a critical number that actually is not a critical number because the function's not defined there. So this should be the first step on every problem that says find a critical number or find the relative min and max. All right, so the derivative, did you rewrite this as sine x squared plus cosine x? Who asked me this one? Miss Abby, was that you?
No, it was Abby.
Oh, Abby. Abby, did you rewrite it this way?
Yes.
Okay, so the derivative of ugly squared is 2 ugly to the first times the derivative of the ugly. What's the derivative of the ugly?
Cosine x.
Mm-hmm. So 2 sine x cosine x plus the derivative of cosine x is what?
Negative sine x.
All right, so I'm just going to change that to minus sine x. All right, I'm looking for critical numbers, so anything that makes that 0 or undefined. Is there anything that makes it undefined? Anything I cannot let x be? there anything I cannot let x be?
No.
No, the domain is still negative infinity to infinity, so there's nothing that makes it undefined. That means we're just looking for what makes it 0. And do you have a wild idea about how we could solve that equation?
You could factor out a sine of x and then set both factors equal to 0.
Exactly. We try to solve by factoring. Now, I just happened to notice something else, and it wouldn't matter if you notice this or not, but, actually, that would make it harder. I was just thinking 2 sine x cosine x is the double angle formula for sine of 2x, but then it would be harder to solve if you had a sine of a 2x and a sine of a 1x. You couldn't factor out anything. So let's go ahead and do what Ivy said. Let's factor out a sine x. And set each factor equal to 0. Now, Miss Abby, did you get the derivative correct?
Yes,
Did you just forget how to solve that equation?
I think so.
Okay. All right. It's been a while since we've solved trig equations, but now you could tell me what makes sine 0, or where in 1 revolution of the unit circle. By the way, did it say, it didn't say just 1 revolution of the unit circle, so we could write and all of the coterminal angles, but we don't have to. We can just say sine is 0 at 0 radians and cosine is 1/2 at pi over 3. Trying to picture my unit circle. 1.6263646 or 2/3 pi. In the second quadrant, cosine would be negative 1/2. So we need the fourth quadrant. 5/3 pi. Right here and right here. Is that okay now, Miss Abby?
Yes.
Okay. All right, what else do you need from the homework? Does anybody else have a question?
Number 37.
37. Let's see. That said find the absolute extrema. Oh, it may not be the same as yours. Is yours 3 cosine x? Or is it arctangent x squared?
No, it is the I forgot the name of this one. It's one of the step functions.
Oh, my 33 is absolute value, or not absolute value, but step function applied to x. Is that it?
Yes, ma'am.
Okay. And then I'm just going to reprint this with the right page. But you said that's your number what?
37.
37. So f of x equals the step function of x on the interval from -2 to 2. Now let me ask you this. If I wasn't given a closed interval here, it just said find the absolute max or min, you have in your head a picture of what the step function looks like?
Yeah.
Looks like a staircase with closed dot on the left end of each stair and an open dot on the right end of each stair. So if I just said, find the absolute max or min, would there be an absolute max over the entire domain of X, or domain of the function? Would there be an absolute max or min from negative infinity to infinity?
No.
No, the stairs would keep going up to the right and the stairs would keep going down to the left. So if you gave me just over its entire domain, there would be no absolute max or min. But if you give me a closed interval, I have a theorem that guarantees there to be a max and a min on a closed interval. And that's why we have a closed interval here. Now, we really haven't talked about how to find the derivative of the absolute or the step function analytically. We don't have a formula for it. You just have to think about what that graph looks like. If you put in a -2, it's going to give you the greatest integer to the left of -2 is -2. And the value of that step function is going to be -2 all the way up to where you hit -1. But the step function applied to -1 is -1. The function value is -1 all the way up to 0. And then you have an open dot on 0. So that's what the step function looks like. So on that interval, what's the absolute lowest y value?
-2.
Yeah. F of -2 is -2, and that's the absolute min. And then what is the absolute highest y value on that graph?
2.
At 2, there's going to be a closed dot on 2. So f of 2 is 2, and that is your absolute max. So here the absolute max and min don't occur at critical numbers. It occurs at the midpoint, or not midpoint, I'm sorry, endpoints. The whole point of 21 to 46 is to say, let me find this for you in the book. If nope, that's not it. Critical numbers can, absolute extrema can occur at the critical numbers in the open interval, but they can also occur at the endpoints. So anytime the directions say, find the absolute max or min on a closed interval, you not only evaluate the function at the critical number, you evaluate the function at the endpoints also. And this is an example where the absolute max and min occur at the endpoints, not at the critical numbers. What would the critical numbers be? Just looking at that graph, what's the critical values for that function?
Would it be at each integer?
At each integer, the function is undefined because there's a discontinuity there. Not only that, but all of the fractions in between the integers, the slope of the tangent line would be 0 because the line's flat. So every number from -infinity to infinity is a critical number of the step function because the derivative is either 0 or undefined for every value of x. But the endpoints occur at -2, or the max and min occur at the endpoints of any closed interval that you give me. All right, what else? Going once. Going twice. All right, I'm going to take that to mean that you have tried the 4.1 homework and found it fairly easy. I did extend the deadline for the 3.7 My Math Lab homework because my math lab was down on and off all day yesterday. So if you haven't finished 3.7 day 2, finish that. And I may have time to get your 4.1 homework in there before pre-calculus starts. I'll certainly have it in there before noon, but I may get it in there pretty quickly. Any questions? Alrighty, make sure you watch the 4.2 video and try the 4.2 homework from the book before we Zoom tomorrow. Y'all have a good day. Bye.
Bye.
Bye-bye.
Bye.
Bye.